along with the rest of the concepts. So let's just begin with it. So the first question that we will be discussing, we have done with wavy curve. So let's say we have x minus 1 whole cube. That's what the question given. Let's say this is given positive. We need to find out the region of x where this expression is positive. So we'll be doing it by wavy curve that we have discussed, well known to us. So first thing that we'll be writing is x plus 2 whole fourth, x minus 3 whole fifth, x plus 6 into x square into x minus 7 whole cube. Now if we take the number line and mark out the roots or the zeros, so first thing that we can see, we have minus 6, then minus 6 we have next is minus 2, then we have next is at 0, 1, then 3, and then 7. This is what we have. Now we'll draw the wavy curve. First one, somewhere here, let's say a point minus 7. If you put minus 7, this will give us negative. At minus 7, this will give you positive. This is negative. So minus plus minus, this is again minus, this is plus, and this is minus. So ultimately minus into plus minus, minus into minus plus, plus into minus, minus. So minus into negative into positive, negative, positive, negative, negative, and ultimately positive. So here the curve is positive section. Now I have told you the trick also, x plus 6. So it's a odd exponent, so it will go opposite. At minus 2 we have even, so we'll go in the same direction. At 0 we have even, so we'll go in the same direction. At 1 we have odd exponent, so opposite direction. So now at 3 we have opposite, sorry, odd, so opposite direction. At 7 we have opposite, so it will go like this. That's what the wavy curve. Now if you look at the regions where this expression is positive, so we have this portion along with this portion along with this portion. So finally x belongs to minus infinity to minus 6. We need to take care of this, whether it is open or closed. Okay, so we don't have equality, so all will be in open. Union open 1 to 3, union open 7 to infinity. That's what the region of x where the expression is positive. Moving on, next question if we discuss. So we have the question x square plus 2 by x square minus 1 less than 2, less than minus 2. That's what is given. Now in that type of cases, first thing, generally we will see that we can't do the cross multiplication, because in inequality we can do the cross multiplication when you know the sign of the denominator. Let's say if it is entirely positive or entirely negative. If we can't decide the sign, then we can't, right? So what we'll be doing here, we will transpose this one. So it will be plus 2 now. So we can write it like this, x square plus 2 divided by x square minus 1 plus 2 less than 0. So very clearly we can take LCM and manipulate it further. So I think we are getting it here is 3x square. Now after that is just wavy curve. So 3x square into x square minus 1. 3x square into x square minus 1, x square minus 1, if you look at it, it's factorizable. It is factorizable, so we can write it like this, 3x square into x plus 1 into x minus 1 less than 0. Now if you do the wavy curve, we have minus 1, 0 and 1. Let's take a value at the extreme of -1. Let's say -2. If we put -2, that will give us positive. That will give us negative. That will give us negative. So ultimately, item is positive. At -1, that means this. We have odd exponent, so it will go opposite. 0, 0 means this one, even exponent, so same direction. And finally this. This was the wavy curve now. What we need the region where it is less than 0. Less than 0 is between there. So finally, x belongs to -1 to 0, union 0 to 1. That's what the region we have got. Moving on to the next question. Mod of x minus 1 is less than 2. Now, if we remove modulus, what will happen with it? -2 less than x minus 1 less than 2, right? What is the property we are applying typically? Here is a negative Okay, so the property that we are applying here is kind of this. Mod of x less than a is between x is between -n and a. Now, at 1, all the sides, so it is -1 less than x less than 3. So finally, what is the x region? Open -1 to 3. This is what the region we got. I'll tell you one more way to think these problems. Some alternative way, another way to think of this type of questions. First of all, we need the knowledge of graph, how to sketch curves. If we look at there, we can sketch mod of x minus 1 curve, right? So mod of x minus 1 will look like this. This is 1, which is the critical point. Now, if we put x equals to 0, this is origin, we will get 1. What we need, x minus 1 modulus curve is less than 2. So we'll draw the line 2, y equals to 2. So this is y equals to 2 line. Y equals to 2 line. What we need, line 2, we need the values less than 2. That means the possible wings are this. And where this is open to us, we need less than 2, not equals to 2. Now for the respective x values, for this, if you put x equals to y equals to 2, what we'll get here is 3. And we put here, we'll get -1. So the respective x value is this one. So that means x belongs to -1 to 3. This is an open because we are not getting the points. 2 we don't have inequality. So it's -1 to 3 open. This is another way to think problems like this. Let's just move on. Next question. We have given 1 less than equals to x minus 1 less than equals to 3. We have two cases here. If you look at it properly, we have this one case and another time is this, right? So if we take the first one, that is more than equals to 1. If you remove the modulus, will it be x minus 1 more than equals to 1 and x minus 1 less than equals to -1, correct? So from there, x is more than equals to 2. Along with it, x is less than equals to 0. That's what we have from the first inequation if we take from the first relation. Now, if you look at the second one, we have mod of x minus 1 less than equals to 3. That is very clear to us. -3 less than equals to x minus 1 less than equals to 3. If we add 1 both side, -2 less than equals to x less than equals to 4. So this is the whole thing we have. We have two inequations and from which we are getting these two values. So finally, the solution set, if you wish to write, what will be the solution set? For that, what we'll do, we'll do a number line. So we have -2, we have a 0, we have a 2, we have a 4. The first case says close to and more. So close to and more means this side. And this one says close to 0 and less. Right? Whereas the second case says between close to -2 and 4. Close 4. We have to take the common region. And why common region? We'll take that region where both of them are satisfied. Now, as the concern, we have a both the conditions. That means we have to take the intersection, and intersection other than common region between them. So the final region from which we can write is x belongs to -2 to 0 union 2 to 4. That's what we have. Again, this scenario, if you look at it graphically, if you look at this scenario graphically, so the curve again we can draw. It's quite of like this. This is 1. This is mod of x minus 1. We need it to be more than 1. This point is 1. That is very clear to us. So it's just that y equals 1 line. Another line we have y equals to 3. It's less than 3 but more than 1. So the y-axis that is concerned is that one. So on that the curve is concerned is this one. This is what the wing of the curve we are concerned about. On which if we draw the, if we put y equals to 1, we'll get 0 and this is 2. And if you put and this is -2. So the region, the curve, as per the curve, concerned curve, the x proper value is between -2 and 0. So what is the concerned value of x? This and this, right? So -2 and 0, yeah, 2 and 4. That's what x is. It's another way to approach like this graphically. Moving on. Next we have okay, we have a question like this: 2 upon modulus 2 upon x minus 4 is more than 1. Find the region of x. Okay, if we take reciprocal both the sides, so we'll have it like this then. It's less than 1. 2 transposed. Mod of x minus 4 will be less than 2. 2 is a positive number, so you can transpose. No, very we have to do. And this one, if you remove the bracket, -2 less than x minus 4 less than 4, 2. 4 added. So between 2 and 6. But that's not the end of the story, because between 2 and 6 we have 4 also. And at 4 that expression is undefined because 2 upon 0 undefined. So basically we can't take 4 then. So we have the ultimate region is 2 to 4 union 4 to 6. That's what the region is. Moving next. Mod of x minus 1 plus mod of x minus 2 is more than 4. X minus 1 plus more. This is more than equals to 4. You need to get the skill of defining these type of cases. Here we have 2 modulus quantities. Sometimes you may find 3 and 4 also. So you have to get the skill of defining these type of cases. Now, if you look at the number line, we have 2 critical points, and one is 1, another one is 2. So basically we have 2 regions between less than 1, between 1 and 2, and more than 2. These 3 regions we have. In these 3 regions, if we define the modulus quantity, so let's say what happens. So the first case that we have is x less than 1. So x less than 1 means left to 1, and we have discussed modulus quantity. Left to 1 means negative. So that will be 1 minus x plus 2 minus x less than equals to 4. First, let's just finish the defining thing, then I'll come to the solving the question. Second case that we have is less than 1 but less than 2 but more than 1, between 1 and 2. So in that case, this is right to 1 means this is positive, and this is left to 1 means this is negative. And third case that we have is more than equals to 2. So all is positive. So this is how we can define them. Now if you come on solving the question, let's just start with there. So it is 2x minus more than equals to 4. That means x is more than equals to 7 by 2. Now that's not the end of the story. We have to understand this condition validates because of this. So that means both the condition has to be have to be valid altogether. Now x more than 2, x more than 7 by 2. What is the ultimate thing we have? Is x more than 7 by 2. Correct? Common region between them. If it is not clear, just go with the number line. Now, from this case, x cancel and 2 plus 1 is 1. 1 more than equals to 4. It doesn't make sense. 1 is not more than equals to 4. It falls. False means we don't have any particular x. So x is null here. There is no certain x where it falls between 1 and 2, where 1 is more than equals to 4. That means what? Its condition doesn't match. It's not true. So that means we don't have any such x. So that means it is null set. Secondly, if you look at this case, it is 3 minus 2x is more than equals to 4. So I think 2x is less than equals to 1. So x is less than equals to half. If x is less than equals to half and x is less than 1, what is the ultimate thing we have is less than equals to half. Now we have to merge all the conditions. If we merge all the conditions, what will happen? X belongs to minus infinity to half closed union close 7 by 2 to infinity. And that's what the region is. Moving on. Okay. Next question we have 5x minus x square minus 6. And that is equals to plus 6. We need to find out the solution and all. Now, if you look at it closely, it's modulus of minus x square minus 5x plus 6. And that gives us x square minus 5x plus 6. Isn't it kind of like this, where mod of fx is equals to minus fx? If you consider this whole thing as fx, so minus of fx is that one. And when does it occur? When fx is negative. If the modulus quantity we have, and inside the modulus quantity we already have a negative, so the modulus job is to make the things positive. So that quantity will automatically come with another negative, so the whole thing makes up to be a positive quantity. And that's what we have here is fx negative. So that means x square minus 5x plus 6 negative of x square, that quantity is negative. That means x square minus 5x plus 6 is positive. That's what we got. That's the inequation we have now. So now if we solve it further, we have x minus 2, x minus 3 more than 0. So x less than 2 and x more than 3. So that's what the region is. Moving on. We need to find out the region of x for which log base x plus 7 is negative less than 0. It says less than 0. We need to find out the region of x. We have two cases to do here. Case 1, when x is between 0 and 1. So at that time, if we x transpose, if we take anti-log, so x plus 7 will be more than 1. As base is between 0 and 1, so now if we transpose, log is now acting as a decreasing function. And for monotonic functions, we change the inequality sign. If it is increasing, then it is same. Decreasing, then it is it will change, right? So x to the power 0, which is 1. So now x is more than 7. 1 minus 7, that is minus 6. X is more than 1 minus 6. Sorry, x is more than minus 6 and x is between 0 and 1. So which condition is satisfying between both of them is x belongs to 0 and 1. That's what the final condition. From this and this, if we take the intersection, that we need to do because both of them to be valid. Now, second case, x is more than 1. When x is more than 1, we have x plus 7 less than 1 again. So x is less than minus 6. Now, what it says, first condition says x is more than 1, but the condition we got for logarithm is x less than minus 6. We don't have any common region. As we don't have any common region, we have nothing to do from here. So final answer is 0 to 1, where we'll find out the value of this expression is negative. Moving next. Log 0.16 a plus 1 less than log 0.4 a plus 1. We need the region of a here. First thing, you can change the base. This is something 0.4 square and this is a plus 1 less than log 0.4 a plus 1. From the log property, like this property we have, a to the power m, base is b to the power n, so it is m by n log a base b. So what will happen in that case, that 2 will come and get outside to be getted and will be divided. So this log 0.4 a plus 1 less than log 0.4 a plus 1. Now here we will be applying the reverse property of that again. So if it is multiplied, it will come in the power. So if it is half, we'll take it in the power of a plus 1. So now it will be log 0.4 root a plus 1 less than log 0.4 a plus 1. That's what we have now. Or maybe we can do it later also. We can do it like little more simpler way is that we can transpose this whole thing here. So it is kind of x half x less than x. So just transpose to half log 0.4 a plus 1 is more than 0. Just transposed and subtract. Now that half we can take with 0. That will be easier way to do. Otherwise that way also we could have done anything. So log 0.4 a plus 1 is more than 0. Now log base is less than 1. That means log is decreasing. Modern decreasing functions, when you remove from the inequality sign gets changed. So that means a plus 1 will be less than 1 now. 0.4 raised to 0 antilog is 1 now. So a is less than 0. But that's not the end of the story, because that logarithm has to be valid. Correct? A less than 0 we got. Logarithm has to be valid. So as logarithm has to be valid, we have a case a plus 1 positive. Log can't be applicable in negative numbers. So a is more than minus 1. So a is more than minus 1, less than 0. So a belongs to minus 1 to 0. That's what the interval is. Minus 1 to 0. Moving next. Next question. So we have 3x plus 5, 9x square plus 8x plus 8 more than 2. That's 9, right? 9x square plus 8x plus 8. Fine then. We have two cases to do it again. First one, the base is between 0 and 1. Let's just see what happens in that region. So now, if it is between that region, if you take antilog, so 9x square plus 8x plus 8 is less than, inequality sign will change, 3x plus 5 raised to 2. Well, now expand it. So 9x square plus 8x plus 8 is less than, what is this coming is 9x square, this is 15 means 30x plus 25. That's what we got. Easily we can see that 9x square is getting cancelled. And if you multiply it further, or if you manipulate further like this, so 30x minus 8, which is 21x, is more than 17. So what is x then? 17 by 21. X is more than 17 by 21. Now, if you look at this case from here, what we are getting x as. So x we are getting, I think, minus 5 by 3 less than x less than minus 4 by 3. I think that is minus 17 here. Minus 17 by 21. We need to take the common region between these two, where both the conditions are valid. Second case, where 3x plus 5 is more than 1. So when 3x plus 5 is more than 1, we'll get the same calculation here with other sign. That means we'll be having same in x square plus 8x plus 8 more than 3x plus 5 whole square. That means we'll be end up at this minus 17 by 21. And from there x is more than minus 4 by 3. We have to summon all these cases. And the final region that we can conclude from here is I think we are not getting any common region between them. 5 by 3 and 4 by 3 and 17 by 21. So if you look at 17 by 21, that gives us almost 0.81. 0.81. 4 by these are more than 1. So we are not getting very much common region from here. And also, if you look at this case, we have more than this but less than this. So x ultimately between minus 17 by 21, sorry, minus 4 by 3 to minus 17 by 21. So that's what the region is. And here we are not getting any common region, right? Moving on. Next question. That's what we have given. Now, this minus is none other than minus 1, right? And this minus 1, if we take it in the exponent of base, that is allowed by logarithm property. So now we will be having it like this, boss base half x square plus 6x plus 9 divided by twice x plus 1, and that is less than log base half x plus 1. Look at it properly, log base half we can neglect and I'm taking the anti-log, but as the base is less than 1, it is decreasing monotonic, and hence the inequality sign will get changed. So final thing that we will be having is x square plus 6x plus 9 divided by twice x plus 1 is more than x plus 1. That's very clear to us. Moving on. What will be doing here? Just transposed. So x square plus 6x plus 9 divided by twice of x plus 1 minus x plus 1 is more than 0. Now take LCM and simplify. X square plus 6x plus 9 minus twice of x plus 1 whole square divided by x plus 1 twice is more than 0, expand it. Minus 4x minus 2 divided by twice of x plus 1 more than 0. So this is minus x square plus 2x plus 7. That's what we are getting upside in numerator. One thing you need to understand here, we can do this is more simplified form. We don't need to write Wavy, we don't need to even. X plus 1 is a positive quantity. As x plus 1 is a positive quantity, this quantity is positive that we know. We can transpose and make it to 0. Eventually, I can tell you one more thing, that x plus 1 is here positive. So actually you can transpose it here and can cross multiply and can manipulate. Ultimately, we'll end up here again. So now, if we take negative outside, so that's what we are getting and the inequality sign will change. Finally, the roots. If we check the roots will come by quadratic formula. It's not factorizable here. So you can apply quadratic formula, or we can go with anything making it perfect square also, anything you wish. Minus 8 equals to 0. So x minus 1 whole square equals to 8. So x equals to 1 plus minus 2 root 2. So that is 1 minus 2 root 2. That is 1 plus 2 root 2. Now x plus 1 is a positive, so minus 1. 2 root 2 is 2.8, that is minus 1.8. Somewhere here minus 1 is. This region says between there, and x plus 1 positive says here. So ultimate region is between minus 1, open minus 1 to 2 root 2 plus 1. That's what the region where this function is valid. Moving on. Next question. We need to find out the region of x. Okay, first thing is if we do it like taking log base half x as let's say a, so that is a square plus a minus 2 less than equals to 0. And we can write it like this, a plus 2 into a minus 1 less than equals to 0. So a lies between minus 2 and 1. That's where a is. That's not the end of the story because we need x, not a. A we have considered, right? Now, we substitute that one by one. So log base half x is less than equals to 1. If we transpose or if we take anti-log, first thing is log base is half, that will be monotonic decreasing. So inequality sign will change and that will be half to the power 1. Just that. Second case it says log base half x is more than equals to minus 2. Again the same thing, x will be less than equals to 1 by 4 then. So what we have is x lies between x is more than half but less than 4. I think there is half to the power minus 2 is 4, more than half but less than 4. So ultimate answer is half to 4. Moving on, next question. Okay, that's what we have given. First thing is little more of manipulation and logarithm properties that we can write as log base 2 to the power 2x. That makes sense, right? Next is minus 2 into x 2 to the power x plus 1 plus 12 more than 5. Sorry, more than 0. 5 we have transpose, 17 minus 5 is 12. That question doesn't seem very okay. I think it should not be like this. Should not any log is there. It's just that. So this will be now 2 to the power x whole square minus 2 into 2 to the power x plus 12 more than 0. Now if we consider 2 to the power x equals to a, so that will be a square minus 2a plus 12. Oh, I'll rewrite the question once. The question is actually this. 4 to the power x minus 2 into 2 to the power x plus 17. That is more than 5. That's what the question is. The question has some error. So that's what the question is. Now, if we transpose log and take anti-log, if we take anti-log, that is 2 to the power 2x that we got clear. That will be more than 32. 2 to the power 5 and more, base is more than 1. So monotonic increasing. So inequality sign will not change. Now transpose it here. So we can write it like this. 2a minus 12 more than 0. 2 to the power x we have taken as a. 2 to the power x we have taken as a. So a square minus 2a minus 12. 6, not 12, I think. It is 15. 15. Now you factorize it. We'll get it like a minus 5 into a plus 3 more than 0. So a is less than minus 3 and a is more than 5. That's what we are getting. So that's not the end of the story again. We need x, right? A is more than minus 3. A is less than minus 3 means 2 to the power x is less than minus 3. And it doesn't happen, right? Because if you can recall, the 2 to the power x curve goes like this. It's entirely positive. Entirely positive. So minus 3 less means more negative. So 2 to the power x will not possess any negative. Next one is a to the a more than 5. So 2 to the power x is more than 5. So what is x then? More than log 5 base 2, taking log both side. As base is 2, base is more than 1, so increasing again. So final region is what? X belongs to open log 5 base 2 till infinity. That's what the region of x. Moving on. Next. So the question is, where's the question? Log x square base x square 4x minus 5 divided by mod x minus 2. That is more than equals to half. Okay, that's what the question is. We have two cases to discuss. First case, x square lies between 0 and 1. So that time if you take anti-log, that will be less than equals to x square raised to half, that is x. And x is positive, that's why it's just x. Base is always positive but less than 1. So x will lie between minus 1 and 1. So actually this will be, shall we take mod x? Well, we'll see that later, maybe. From there it is minus 1 to 1. So better to take mod x. X is negative, then it will be that way. Modulus quantity positive. So let's take it up there. So 4x minus 5 less than equals to mod of x minus 2. Here again we have two conditions to do. One thing is from here two parts will come. First part, modulus function we have mod x, the base is critical point is 0. Once we have left to 0, right to 0. When is less than 0, so 4x minus 5 less than equals to minus x, and here critical point is 2. Entirely it is left side, so that means it is 2 minus x. So what we are getting here in that case 0 minus 1 less than x less than 0. And if we simplify it, we'll be having it minus 2x plus x square. Transpose them, x square minus 6x plus 5 more than equals to 0. So x minus 5 into x minus 1 more than equals to 0. That means x is less than 1 but more than 5. X is less than 1 more than 5. We have this condition only to be satisfied. So ultimate region is minus 1 to 0. This is the final case from the both of the region minus 1 to 0. Next one. We have another case where 0 less than x less than 1. In that case, 4x minus 5 less than equals to x, but it is 2 minus x again. So it will be 4x minus 5 less than equals to 2x minus x square. So transpose x square minus 6x minus 5 is less than equals to 0. If we factorize, it is x minus 6 into x plus 1. Or is it factorizable even? No, it's not factorizable. You have to check the discriminant. Discriminant is also positive. We'll go with the roots now by quadratic formula. So if we write it like this, so it will be x minus 3 whole square plus 9 minus 10. So it is less than equals to 14. So root 14, 3 minus root 14, 2, 3 plus root 14. Root 14 is less than 4 but more than 3. But it says between 0 and 1. So ultimately we are getting this case valid. Okay. So that's what we have. Secondly, we need to find it for more than one case, x square more than 1. X square more than 1. So we have x is less than minus 1, x is more than 1. We have to do the cases along with it. Along with it, we will do 4x minus 5 divided by mod of x minus 2 to be positive because log has to be valid. So 4x minus 5 has to be positive. So x is more than 5 by 4. Along with this, x not equals to 2. Base should not, denominator should not be 0. Okay, that one I think is coming 2 here. So it is x minus 1 whole square less than equals to 6. So 1 minus root 6 to 1 plus root 6. Minus 1 minus root 6. 1 minus root 6. So root 6, this is plus here. So this. And we need to be positive. So 0 to root 6 plus 1. So ultimately we are getting it till root 6 minus 1 to 2 from this case. And it has to be x minus 2 has to be positive. So that is there. Union. But else case we are getting more than 1 and more than 5 by 4. Along with we have this case. We have got it till 5, I think. So it's 2 we can't take. So between 2 and 5, we got it till 5. Yes. That's what the case is. So that's what the region of X. Moving next. Sometimes these calculations will find lengthy. So you have to get it that way. Moving next. Half base log base half x more than log base 1 by 3x. What we'll do, just we can write it like this. Less than 1 upon 1 by 3 base x. So half base x is more than 1 by 3 base x. You transpose. Okay, now from there we will have two cases again. Base is x. We have taken reciprocal. The logarithm property that we have applied is log a base b equals to 1 upon log b base a. Okay, that's what we applied here. And then inequality properties. Reciprocal means inequality sign will change. Now, if you look at this, two cases again. X is between 0 and 1, and the other case is x is more than 1. When x is between 0 and 1, so that is monotonic decreasing. So if you remove logs, so half is less than 1 by 3. That's what we are getting. I hope all the cases are clear. Okay, we did one thing wrong. This is just applied this property. So it is that. So inequality sign is now it will change. So in that case, half is more than 1 by 3. Here we are taking the reciprocal. Here we apply the logarithm property. So logarithm property means inequality sign will not change. That one I have written wrong. Now as we have taken reciprocal, so inequality sign we have changed. Now x is between 0 and 1 means monotonic decreasing on log. So half more than 1/3. Half means 0.5, 1/3 means 0.6. So that is true. True means this interval is accepted. Now x is more than 1 means if we remove log, inequality sign will not change. This is false. False means this is not correct interval. So ultimate interval is x belongs to 0 to 1. That's what we have. Moving next. Next question. More than 1. So how will we do that? Let's just write this one as it is. And this one I'm writing reciprocal, that logarithm property again. That is more than 1. Right? Log a base b is 1 by log b base a. That's what we applied here. Expand it a little bit. So is it 2 plus log x base 2 divided by log x base 2 into 1 plus log x base 2 more than 1. That's what we got. Now let's take log x base 2 as t or a, anything. So it is 2 plus a divided by 1 plus a into a minus 1 is more than 0. A plus 2 minus a square minus a divided by a into a plus 2, 0. A cancel. So it's a square minus 2 divided by a into a plus 2. That is less than 0 here. Multiply. Wavy curve after that. A minus root 2 into a plus root 2 into a plus 2, that is less than 0. Wavy curve we are doing here. We'll draw the number line. Again the same thing as per wavy curve we know. The regions are points we have minus 2, minus root 2, 0, root 2. That's what we got. We'll take a point, let's say minus 3. Minus 3, minus 3 minus root 2 negative, minus 3 plus root negative, negative and negative. Ultimately positive. So this is how the wavy curve will go. But the neat portion, negative portion is this and this. Correct. So finally, a belongs to minus 0 in open. Now a was log x base 2. So log x base 2 is belong to minus 2 to minus 0 2 that we have. Now we need to find out x from there by taking antilogs and all. So if we take antilog after that, just simple after that. Antilog base is 2, so straight away that 2 to the power minus 2, that is 1 by 4, and plus 1 to the power. Okay. I think union 1 to the power root 2. I think that's what we got. A plus 2. Okay, okay, okay. I did one thing wrong here. That was not 2, that was 1. That was 1. That was 1. So that was 1. So this is minus 1. This is half then. Okay, that's what the answer is. This. Notice that 1 we had, I have written 2. So that is minus 1 will form here. Otherwise, everything is correct. That's what the region is. Moving next. Half to the power x square minus 2x is less than half to the power 2. Very simple question. You need to get the idea. As the base of the exponent is less than 1, so it is monotonic decreasing again, right? And it is happening. So if we compare, we'll be having this inequality sign change. So it is finally 2. So x square minus 2x plus 1 more than 3. So x minus 1 whole square is more than 3. So mod of x minus 1 is more than root 3. So finally what is we can write here is 1 minus root 3 to 1 plus root 3. That's what the region is. Next. Okay, we need the x region here again. Interval of x. Quite of a similar thing. It's 0.9909 is given. So we can write it like this, half log 0.3. Correct. Because it is 0.3 whole square, 2 outside is just that. Now transpose this whole thing. So it is half log 0.3 x minus 1 less than 0. Half you transpose with 0. Let's just transpose this half with 0. So we will be having log 0.3 base and x minus 1 is less than 0. Now take antilog. If you take antilog, the base is again less than 1. So that means x minus 1 will be more than 1. So what is x then? X more than 2. 0.3 raised to 0 is 1. So x more than 2. So final interval is 2 to infinity. One more thing, if you can notice, we don't need to check the validity of x because x is more than 1. What the validity says, but we are getting x is more than 2. So ultimate thing is x more than 2. Moving on. Next question. Okay, that's what the sum is given. We need the region of x. One of the most foolish thing in this problem is this one. It's none other than 0, right? Because log 1 is 0, doesn't matter what valid base we have. Now you take anti-log. So half is there, base is half, right? So base is less than 1. That means when you take anti-log, the inequality sign will change and half to the power 0, 1. Again, you take the anti-log. Again, if you take anti-log, x square minus 4. Now anti-log 5 is the base, which is more than 1. So it is inequality sign will not change. 5 to the power 1 is 5. So x square is less than 9. So x is between minus 3 and 3. X is between minus 3 and 3. That's not the end of the story again. We need logs to be valid. That means inside this log, what you have is to be positive. So log base 5, x square minus 4 is positive. So what you have is x square minus 4 is less than 1. So x square is less than 5. So between minus root 5 and root 5. Along with it, x square minus 4. Okay, that thing I wrote wrong, I think. It is x less than root 5 and minus root 5, and x is more than root 5. Greater than we have. Along with it, we have x square minus 4 positive, so that log is valid. So that means x is more than 2 and less than minus 2. If we sum all of them, so it is minus 3 minus root 5 and minus 2, 2 root 5 and 3. It says more. Her condition says there. So ultimate common region is this. So final region is minus 3 minus root 5 root 5 root 5 3. All is open, I think. All is open. So that's what we got. We need to take care of the logarithm. Inside the logarithm has to be valid also. Next sum. More than equals to minus 1. Sorry, given here. Now, two cases again. First case, base. 1 minus x is less than 1. So if we transpose this, 1 less than minus x less than 0. So minus x will lie between 0 and minus 1. Sorry, minus 1 and 0. I think that is correct. One we have subtracted, right? So it is 0 to 1. That's what we are getting if you simplify this. Now, if you take anti-log, x minus 2 will be less than equals to 1 minus x raised to minus 1. One minus x is a positive quantity, and this is minus 1 means it is 1 upon this. Cross multiply. X minus 2 into 1 minus x is less than equals to 1. So x square minus 3x plus 2 or minus 2 minus x square minus x square 2x and x, no, minus x minus 2 plus 2x and x. 3x is correct. Less than equals to 1. So x square minus 3x plus 2 more than equals to minus 1. So plus 3 is more than equals to 0. If you look at this quadratic, the roots, if you look at the discriminant, b square minus 4ac, negative, that means quadratic is positive, that is true. True always, all real numbers. So this is the final region we have. From the first case, x is between 0 and 1. Second case, this is 4 into 3, 12. No, 9 minus 12 is negative. Negative means it's quadratic, it's positive. Second case, we have like 1 minus x is more than 1. So x is less than 0. X is less than 0. X square minus x plus 3 will become less than equals to 0, I think. So that is from here, it is null. Because every time that quadratic is positive, if we merge both the cases, what will happen? We have no common region, right? Or we are getting 0 and 1. I think something is not correct here. Let's just check this portion once again. So along with it, x minus 2 has to be positive, right? X minus 2 is positive means x more than 2. Okay, okay. In that region, this is log is not getting valid. So here also x is null. We don't need to go through it further. First case we have chosen that 1 minus x is positive, but more than 1. At that time, x minus 2 is always positive. So x is more than 2 every time. X is more than 2, but we are getting x is between 0 and 1. That means we have no common region between there. So this base is valid, but the logarithm is not coming to be valid. Also, 1 minus x is more than 1 means x less than 0. X less than 0 is coming here. X less than 0, we have x is more than 2. X is more less than 0, but x is more than 2 to be the log valid. So again, we are getting no common region. So finally, this expression doesn't exist. So the region of x is x belongs to null set. Be little careful while solving these questions. Next one. Two minus log base 2 x square plus 3x more than equals to 0. Transpose a little bit. So we'll be having it x square plus 3x is less than equals to 2. Take anti-log. So x square plus 3x is less than equals to 4. For transposed. So we have it like this, x plus 4 into x minus 1. So x is between minus 4 and 1. Again, that's not the end of the story because we have to check the log. Log has to be valid. So x is less than 0 or minus 3 and x is more than 0. So finally the common region, this is minus 4, minus 3, 0, 1. It says this outside and this says between minus 4 and 1. What is the common region? This and this. So ultimate region is minus 4 close to, I think, to 3 open, minus 3 maybe this you could find in the options. That's what we have, right? You have to check with the logarithm. Don't take that one as a final answer. Sometimes you'll find this is an option, which will be to make you full. You have to check this also, that logarithm has to be valid. Every time you're solving log questions, check with the expression if it is there, check the log is valid or not. Fine, then we are closing this session here. Next session we'll move forward with the other concepts. We have hardly any concepts left. It's just the problems and all. Chalo. See you next session. Thank you, everyone.